In informed search, we're going to use some domain knowledge in which we are going to ask the question whether we are getting to the goal. So remember, for a uniform cost search, we don't have any information about how far we are from the goal. So we kept exploring around the start state until we reached the goal, but we were really erring around that. So the question is, are we getting to the goal? And to respond to this question, we could use what we call a heuristic function that estimates how close a state is to the goal. So a heuristic is not a perfect measure, but it doesn't have to be perfect. However, it turned out that it can be very useful if you want to do the search. So example of strategies include greedy best first search and A-star search, which we are going to see today. And also there are other extensions such as IDA, which is iterative deepening A-star, a variant of A-star to do the search based on the heuristics. In the map example, we could use a heuristic that gives us the distance as a straight line between the cities. So for example, if our goal is to reach Sault Ste. Marie, we're going to use this heuristic that gives us the distance between any city and Sault Ste. Marie. Sault Ste. Marie is here. That's going to be, we're going to have all these distances, just an approximation of how far is Sault Ste. Marie from this city. Okay, so typically Sault Ste. Marie to itself is 0, but then we have distances in kilometers from all the other cities. So how can we leverage that heuristic in order to make a better search? Is the question of A-star and greedy search methods. So first of all, for greedy search, we're going to use an evaluation function h of n, which is the heuristic. Hn estimates the cost from n to the closest node. So we're doing our search, and suppose we reach a node n, and the node n would be an estimation actually from n to the goal. We would have a function h of n that tells us how far is n from the goal. So for example, in the map that we have with the heuristic of the straight line distance, so the heuristic is HSLD of n. So from any node, we need to know, we can use this heuristic that tells us how far are we from the goal of Sault Ste. Marie. So it's a straight line from n to Sault Ste. Marie that we are going to use in the search. So greedy search will expand the node that appears to be closest to the goal. So we're going to have different possibilities of exploring the nodes, node 1, node 2. What would be, we have h1 of n, h2 of n, and we're going to prioritize by this h function in order to pick the next node to explore. Greedy search will use an algorithm similar to UCS in the sense that we also are prioritizing in a queue, in a priority queue by some cost, with the exception that everything is similar except that the cost in this time is actually based on h of n, the heuristic, instead of it being based on the total cost of the path till n. So we're going to change the cost from g of n to h of n, and this is our greedy search algorithm. Let's check it on the example of the map. So let's see how the greedy search algorithm works on the example with the map. Starting from Saint Louis, we want to go to Sault Ste. Marie. So the initial state is the set of Saint Louis, and this is put in blue here to say that it has so far the shortest distance to the goal. Saint Louis is far with a straight distance with 180 kilometers from Sault Ste. Marie. Okay, so we're going to expand this node. It becomes explored. We put it in orange by the color conventions we have decided. So from Saint Louis, we can go to Chicago, Kansas City, Little Rock, or Nashville. We are putting here the numbers that are actually the straight distance between Chicago and Sault Ste. Marie, the straight distance between Kansas City, and so on and so forth. These are the heuristic numbers we had on the table before. So it seems like Chicago is the best choice because it seems like the straight distance between Chicago and potentially Sault Ste. Marie is 107, which is the smallest of all. We're going now to explore the city of Chicago. So the children are Duluth, Omaha, Pittsburgh, and St. Louis. So St. Louis won't be put in the fringe simply because it is already explored. But the other ones that are in the fringe are Omaha, Pittsburgh, Kansas City, Little Rock, and Nashville, and also Duluth. So among these cities that are actually in the fringe, we are going to pick Duluth. That seems to be the closest to the goal. After that, we explore Duluth. Duluth will have Chicago, Helena, Omaha, Sault Ste. Marie, and Winnipeg. So actually, Chicago is not added because it's already explored. However, Helena, Omaha, Sault Ste. Marie, and Winnipeg will be added. So far we have in the fringe this city is in gray or in blue. The blue means actually that this is the best choice in terms of heuristic, because it's actually Sault Ste. Marie itself, we reach 0, which is the straight distance between Sault Ste. Marie and itself. So the path would be really going from St. Louis to Chicago to Duluth to Sault Ste. Marie. Okay, so this is how greedy search would work. On the map, it's going to look like this. So the greedy would go from Sault Ste. Marie to Chicago to Duluth to St. Mary, and the path in this case would be 104 plus 157 plus 110. It's greedy, but we are not going to actually 5, 6, 7, and 3. So the path is actually 371 kilometers, which is actually not the shortest one. I'm going to see that we can get the shortest one using the A-star algorithm. Okay, so the second example that we give you with the map, I'm not going to run the whole tree, but in the previous example, going from Las Vegas to Calgary, we saw that BFS, DFS, and UCS has been really erring around to find a solution. With greedy search, it's way straightforward. It's much better. With greedy search, it's a better search because we're going to we know some information about the goal, so we're going to go straight to the goal. The path that is successful will be Las Vegas, Salt Lake City, Helena, and Calgary, which actually is the shortest path between Las Vegas and Calgary. Okay. So in the previous example, we saw in the informant search, we had to go from Las Vegas to Calgary, and we saw that we actually have been going around to search for the best, for the optimal path. So using greedy search, we are doing a better job, as we are going from Las Vegas to Salt Lake City, from Salt Lake City to Helena, and then to Calgary. So the path would be of 89 plus 116 plus 130. It seems like a better choice than going all the way to Atlanta and then going back to Calgary. So this is we have found some very long path or very lots of search until we find Calgary.